Let's take a look at the first quiz of the Secureum Bootcamp. More specifically, this is the race number 0 of the Epoch Infinity. And the first question here is about the use of Pragma in this little snippet here. And the use of Pragma, we have it here in the first line. In this specific snippet, this Pragma basically specifies that it requires a Solidity version that is at least 0.60, but it can be, this 0 can be anything higher. So the actual compiler version used could be 0.65. It can be up to 0.612 because that's the last compiler version that exists for the 0.6 versions basically. And there's a common misconception here that people have because they think that somehow the compiler can automatically switch between versions via this Pragma, or that a compiler is, or the Solidity compiler is able to somehow compile different versions of Solidity. But that's not correct, because when you install a Solidity compiler, this compiler's version can handle exactly that Solidity version. So there's a one-to-one relationship between the Solidity compiler version and the Solidity version, this version of the language basically. So you cannot expect a compiler to compile anything else but its own version. And what this Pragma does is basically it tells the compiler, look, I have the requirement that you need to be at least 0.6, but you cannot be 0.5 or 0.7. That's not possible. That's not what I need to be compiled basically. That's not what I'm compatible with. And the compiler, if it is for example 0.6.5, then it can see this Pragma and can be, okay, I'm the right version. But if the Pragma tells something else, the compiler will abort and tell you, I'm not the right guy to handle this, and you need to install someone else, basically. There are frameworks like Foundry that can automatically handle Pragmas and actually do switch the versions according to what is needed per file. But it still doesn't allow you to actually mix different Solidity files with each other, because you can you can include a different Solidity file into yours, right? You can import a library or a contract into your contract, and that comes from another file, and this other file will too have a Pragma which specifies a Solidity version, but those need to be compatible with each other. And the one with the most specific Solidity version basically wins, because you need to use that version to be able to compile it. Basically, you have to imagine that all of the files, all of the Solidity files you include, they all get flattened into a single file with all of the Pragmas. And then the compiler with that version tries to compile this entire file with all of those Pragmas, and if any of those Pragmas does not match what the compiler that is installed can provide, then the whole thing aborts basically. The only way around this basically is to compile both contracts that have different Solidity versions separately, then they have separate bytecode, and you can deploy each of them at a different address, and then you can have them communicate with each other by having interfaces, because an interface, if you can adjust an interface to work with any version. So basically, if you have an interface for a contract that has an incompatible version, you can use that interface, make it compatible with your version. They're probably very similar because interfaces don't really contain much, so it shouldn't take much effort. And then you can tell the interface, basically just tells the Solidity compiler how your contract can communicate with another contract via the ABI standard. And because this is like a standard way to communicate between contracts, the version doesn't really matter. But otherwise, you have to be, like, you cannot expect the compiler to just switch automatically between versions and somehow magically work. So that's the common misconception I just wanted to clear up. When we look at the rest of the contract, we see that it's basically just an empty contract. It's contract test, but we are to assume that there is actually other functionality that is correctly implemented, and it works without modifications across 0.6x, 0.7x, and 0.8x. So we are to assume that this empty contract is actually not empty. So now looking at the first option, it says the use of pragma in this snippet is incorrect and will cause a compilation error. The use of pragma is correct. It will not cause a compilation error. It will cause a compilation warning. As you can see here, I pasted it into Remix and it compiles fine with 0.6.12. And we get a warning because this little license header thing here is missing basically. But aside from that, it compiles just fine. There's no issue with that. So option A is not correct. Then we have option B. The use of pragma here allows testing with 6.11, but accidental deployment with buggy 6.5. So it basically says that this allows compiling with two different Solidity versions, which is correct. It allows compiling with both 6.11 and 6.5. So that is a correct option. But many people here were confused because why buggy? I thought the assumption is that it is correct and it works across all the 0.6.x compiler versions. So why can it be deployed with a buggy compiler basically? But it's important to remember here that this quiz, the specific quiz, is about security best practices and pitfalls, and that even if we assume that this code's functionality is working as intended, it doesn't mean that a compiler cannot introduce unexpected bugs into it, basically bugs that don't affect the actual functionality of the contract negatively, but bugs that somehow make it possible to do things that shouldn't be possible additionally to the normal functionality. So indeed, the problem is that a developer could do all of the unit tests and manual testing while compiling with one version, and then later when he actually deploys it, he uses a older version which he did not do any tests with, and then that maybe introduces an issue into that contract that would have been found if all of those tests had been done with the correct version. So that is a bad practice. But nonetheless, B is correct because both versions are allowed. The next option is that the use of pragma is illustrative of risks from using a much older Solidity version. Assume current version is 0.8.9. So if we assume that the current version is 0.8.9 and we are creating a new contract with a version which wants the Solidity version 0.6, that is indeed illustrative of the risks of using an older Solidity version, because at this point it would be much older. And the problem with that is that new versions usually contain much more bug fixes, and new versions also come with many security features that make it easier to develop safe contracts. In case of 0.8, it comes with an automatic check against integer overflows, something which before we needed to use the SafeMath library, and if we forgot about it, if we forgot to use it, then we would have potential overflows, and that would be really bad. And that is why we should try to use a current Solidity version, but probably not the most current one. If the most current version is 0.8.9, we probably shouldn't use that one. We should take a look at the changelog and look which of these, like how long have the versions been available. We should probably choose one that has been available for a month or two. So the most critical bugs would have been found by now, hopefully. And maybe also we should choose a version that doesn't really contain any new features, nothing fancy, and nothing that hasn't really been thoroughly tested yet. The version that we choose should contain mostly bug fixes, basically. So indeed C is also correct, because using 0.6 in a project when 0.8 is available is kind of bad. None of the above cannot be true, and that's that.